Find the slope of the line that passes through the given points. Recall that we use the formula y2 minus y1 divided by x2 minus x1. Here we'll subtract y2 minus y1 divided by x2 minus x1. So when we subtract a negative, we can change that to adding a positive. Negative 6 plus 12 is positive 6. 2 minus 12 is negative 10. That reduces to negative 3 over 5. A line passes through the points negative 16, negative 6, and 23. Another line passes through the points 12, 14, and negative 4, 6. Do the two lines intersect? Explain. For them to intersect, they have to have different slopes. Let's do the first one in red. y2 minus y1 divided by x2 minus x1. Remember, subtracting a negative can be changed to adding opposite. Uh, 36 both have a 9 in common. It takes 1 9 to make 9 and 4 9s to make 36. y2 minus y1 divided by x2 minus x1. Six minus 14 is a negative 8. Negative 2 minus 12 is negative 14. These both have a 2 in common, or a negative 2. Hold on, it should be a negative 4 here for the x2. Negative 4 minus 12 is a 16. So 8 and 16 both have 8 in common. So this is 1 and 2. Since they have different slopes, they will intersect. Line L crosses the y-axis at 5 and has a slope of negative 1. The equation 8x plus 2y equals negative 14 represents the line Q. What is the equation for line L? Well, we have a slope and a y-intercept, so we can write it in slope-intercept form. The slope is negative 1, and the y-intercept is 5. What ordered pairs, if any, satisfy the equations for line L and Q? So we now have two equations to create our system. We can replace y in this equation with negative x plus 5. Distribute here. Combine our like terms. 8x minus 2x is 6x. Subtract 10. Divide both sides by 6. And we get x equals negative 4. And we'll plug it back in. Subtracting negative 4 is the same as a positive 4. and 4 plus 5 is 9. So the ordered pair that satisfies both equations is -4, 9. Line N and P intersect. The equation y equals 2x plus 9 represents line N. And line P passes through 5, 1 and -1, 1. What is an equation for line P? We can use point and slope form. Here I see that the y values subtracted and the x values subtracted. That would give us 0 and -6. But 0 divided by -6 is 0. So for point slope form, y minus y1 equals m, the slope, times x minus x1. Well, 0 times anything is 0. I can add 1 to both sides, and this equation is y equals 1 for part A. So if we substitute that in for the y value in the other equation, we end up with 1 equals 2x plus 9. Then divide by 2 on both sides, and x is equal to -4. So x value is -4, and our y value is 1. For problems 4 through 6, the equation of one line is given. Turn over a card to reveal information about a second line. Record the information in the table, then solve the problems about the two lines. In class, we'll have 3 different cards with lines that could be possible lines that you flip over. Let's assume that you flipped over line T, or card T, for problem 4. So we're going to place T on the blank for line T. And the information from the card is that the slope is 1/2, and it goes through the point -10, -1. So to write the equation of that line, we have y minus y1 equals m times x minus x1. But recall we can change this to adding the opposite. You might also distribute. So we have y plus 1 equals 1/2 x plus half of 5, or half of 10 is 5. If we subtract 1 from both sides, that gives us the equation y equals 1/2 x minus 4. Notice these two lines have the same slope, but different y-intercepts. So this has no solution. Now let's move on to line L. And this time, let's assume you flip over card Q. Card Q says you have a slope of -2 and an x-intercept of 3. Careful because this is not a y-intercept. The way that you can interpret that is that it goes through the point 3, 0. So we used the point slope form. We have y minus y1 equals m times x minus x1. You can distribute here. We don't need the minus 0 anymore. Negative 2 times negative 3 is negative 6, positive 6. We can substitute this into the other equation using the substitution method. That would give us negative 2x plus 6 plus 4 equals negative 3 times x plus 2. We'll need to distribute here and combine our like terms. 6 plus 4 is 10. Negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. Let's add 3x to both sides. Negative 2 plus 3x is x. And let's subtract 10 from both sides. X is negative 16. Now we'll plug it back in to the equation. Y equals negative 2 times our x value plus 16. Negative 2 times negative 16 is positive 32. And 32 plus 16 is 48. So the coordinates of our solution here would be negative 16, positive 48. Excuse me, not 16. It should be 6. So it should be 38. Plus 6, not plus 16. For line P, we have negative 4x plus 2y equals 12. And we're going to pair that with line N, which is through the points negative 2, 7 and 2, negative 5. So we'll need to start by finding the slope. y2 minus y1 divided by x2 minus x1. Negative 5 minus 7 is negative 12. And 2 plus 2 is 4, giving us a slope of negative 3. Now we'll need to write it in point slope form. Y minus y1 or y, we can use the 7, equals m times x minus x1. Remember, change that to plus a positive 2. Let's change this into slope-intercept form to make it easier for substitution. Here we're going to distribute that negative 3. So negative 3x, negative 3 times 2 is negative 6. Add the 7 to both sides. And the equation of the second line is 3x, y equals 3x plus 1. We're going to replace y with negative 3x plus 1. And distribute here. Combine our like terms. Negative 4x and negative 6 makes negative 10x. Subtract 2 from both sides. Divide both sides by negative 10. 10 divided by negative 10 is negative 1. Then we'll substitute that back into the equation to solve it for y. Negative 3 times negative 1 is positive 3. And 3 plus 1 is 4. So the coordinates here of our solution should be at the point negative 1, positive 4. There are the possible solutions with the different combinations of lines. 7 says line A has y-intercept of 5 and a slope of 4/3. So let's write the equation for line A. mx plus b. Then line P passes through the point negative 14, negative 17, and 8, negative 6. Find the solution if it exists. Well, first we're going to do y2 minus y1 divided by x2 minus x1. Negative 6 plus 17 is 11. 8 plus 14 is 22, which reduces to a slope of 1/2. So I'll write it in point slope form. Y minus the y value equals m times x minus the x value. We can distribute here. Half of negative 8 is negative 4. So now I have these two equations to work with in our system. They are both equal to y, so I can rewrite that equation as I personally do not enjoy working with fractions, so I'm going to do what I call fraction busting. A common denominator between 2 and 3 is a 6. 6 times a half is 3. 6 times negative 10 is negative 60. 6 times 4 is 24, and 24 divided by 3 is 8. And 6 times 5 is 30. Now I will subtract 3x from both sides. 8 minus 3 is 5. I will subtract 30 from both sides. Negative 60 and negative 30 is negative 90. Then divide both sides by 5. And I get x is negative 18. But we need to plug it back in to solve it for y. Half of negative 18 is negative 9. Negative 9 minus 10 is negative 19. So the coordinates for where these two lines intersect is negative 18 and negative 19. That is the end of lesson 14, and I think the end of module 5 as well.